Hello, my name is Michael. I'm a third year computer engineering major, and today I'll be going over number 7 of chapter 1, part B in the chemistry workbook problems. So, it's asking what is the mass of the graduated cylinder? Okay, so we want to solve for mass, and we're given information about the inner diameter, the outer diameter, and density. So, if we look at the cylinder diagram to the right of the problem, you'll see that there's a outer radius, or like an outer portion that's solid, and then a hollow portion that's used to carry solution. So we want to be solving for just this ring portion right here, and all of it below as well. Okay, so just think of it in terms of pure volume, or actually before we get to that, let's look at the information we're given. So we see right here we have the inner diameter, the outer diameter, and the density. So we could actually use density to solve for the mass of the cylinder, and I'll explain why. So for density, it's defined as density equals mass over volume. So if we solve for mass itself, we get that the mass of an object equals its volume multiplied by its density. So we're already given the density of our cylinder in the information given above. So we need to solve for the volume of our cylinder. And without worrying about the hollow portion of a cylinder, the volume of a cylinder, or volume of a cylinder, that's CYL, it equals to its area multiplied by its height. Alright? So if we break that down even further, the area of the cylinder, or just one cylinder in general, let me create more space. The area of a cylinder would equal to pi r squared, because the cylinder, or on top of the cylinder, it looks like a circle. Okay, so now that we have information, we need to actually solve for the area of our cylinder, since it's actually hollowed out. So I'm actually, I am actually going to draw out the overhead view of a cylinder. So if we see right here, we have an outer portion, and then we have an inner portion, and all we care about is the shaded solid area, because the inside is hollowed out. So we can think of this whole area of the circle equals the area of the larger circle minus the area of the inner circle. So we've already been given information for that, where the diameter of the outer circle is 34 millimeter, and the inner diameter, I'll just put lowercase d, is equal to 32 millimeters. So for solving for this area, we could just subtract the area of the the smaller circle from the outer circle. So let's do that right now. Let me create more space. The area of the outer circle, or the larger circle I mean, that's equals to pi times radius squared, but since we're only given the diameter, we actually just solve for the radius, which is pretty much the diameter divided by 2, and then we square that, subtracting the area of the smaller circle, which is pi times 32 millimeters divided by 2 squared. And let me get it on my calculator. We actually get that the area of our circle is pi times, let's see, 17 squared. That equals to 289 minus 16 squared. That goes to 33 meters. So we would get 33 millimeter squared times pi as the area of our cylinder. So if you plug in back to the formula above, let me actually scroll up to get it. Let's see, mass equals volume times density. Or actually, we solved for the area of our cylinder, but now we need to solve for height. Alright. So to solve for height, we can actually use our answer from part A, which is this portion right here, the 0.1243 centimeters per 1 milliliter division. Because our cylinder is 100 milliliters, it's going to have 100 1 milliliter divisions. So to get our height, we could simply state that is equals to, let me scroll more to the right to get more space. The height is equals to 100 milliliters divisions. We have that many for how tall it is. You can multiply it for every 1 milliliter division. We have 0.1243 centimeter, and we would get our height to be 12.43 centimeter. Okay, so using our height now and our area, we can solve for the volume of our function or of our mass and then plug in the values now. So using those two values, the height equals to 12.43 centimeter and the area equals to pi times 33 millimeters squared. Let me drag the formula so that we can solve for it. Okay, so now that we have that, let's solve for our formula where the mass of an object equals volume times density. Alright, where our volume is equals to area times height. Okay, so mass equals volume, where our area is pi times 33 millimeters squared. Multiply that by our height, which is 12.43 centimeter. And if you look at our equation, we see that our units don't match, and we'll be able to actually convert it to the units we want after multiplying by density as well. And our density, let me actually get that as well. Our density is 2.23 grams per centimeter cubed. So let me multiply that out as well. 2.23 grams per centimeter cubed. So in our problem, we would want to cancel out the centimeters cubed right here that I'm circling, and we already have 1 centimeter on top over here. So we would need to convert this millimeters to centimeters, and we could do that by using our conversion factor. So let me create more room again. So our conversion would be millimeters on top in our equation, so we would be millimeters on bottom. So for every 10 millimeters, we'd actually hit 1 centimeter. And since our value was millimeters squared, we just square this whole conversion factor. And then now we can solve for our mass. So after getting my calculator, I'll be solving. Let me plug in the values. Pi times 33 times 12.43 times 2.23 divided by 10 to the second. We get a mass of 28 0.7369 grams. And if you use significance figure, where our most accurate unit is two significant figures over here at 33 millimeter, we will simplify this to get 29 grams, which is the mass of our cylinder. And that is the end of the video.